I hope you had a pleasant trip to Amsterdam. And I'm going to present some part of my recent research regarding identification of potentially harmful requests and reporting them, of course. And I'm going to say in the beginning that I'm sorry, but I'm going to discuss slightly a bit of graphs, not even graph theory, but I've noticed that anytime I speak about graphs, in most of people's minds something turns and they just switch off. They say, well, it's definitely black magic. I don't want to have anything to do with it. So please bear with me. It's going to be very simple and hopefully understandable. And so let's start then. Well, probably you are all well aware about the state of internet security, but just to put some numbers down to it, there are some reports from recent years that state that there are companies that do penetration testing and report them, or at least report some summary findings. And the three reports that I had found recently were from Ivy's Whitehead at Symantec, and all of them claim that well, the majority of websites are vulnerable. If you went to the keynote presentation just an hour ago, you probably noticed how easy it is to make a wrong website. So that's no news, but the scale of it is really astounding. I mean, 70–80% of websites vulnerable. That's just really amazing. I have a friend who lived in Cairo in Egypt, and he was also a security guy. And he said the security there was so terrible that you basically had holes in every single application that he touched. And he sent reports, for instance, to mobile companies, explaining to them how much SQL injections they have in their applications. And the answer was, well, so what? Why would anyone would like to abuse it? That wouldn't be fair, right? So he ended up with finding an exploit that just cleaned his bill, a mobile bill. So he used the mobile phone for a couple of years free of charge. And then he moved to Switzerland, so that's why I can tell the story. Also, Symantec reported that in just one single month of May 2012, one single malware, which is Lisa Moon, was responsible for about 1 million successful SQL injection attacks. That tells us what is the scale of the problem. So what I'm going to discuss is a method that I have developed to identify certain class of attacks. Of course, we all know that cross-site scripting is probably the most widely spread vulnerability of the websites, but that's not all. So I'm not going to talk about XSS here. I'm going to talk about other exploits which are based on abuse of path traversal, which may consist of multiple attempts to perform some thing and failing during doing so. Forceful browsing, so accessing directories that shouldn't be accessed from normal use, and unusual usage patterns. And just one more thing came to my mind. Exactly a week ago, I was speaking to the dean of my faculty, and he said, well, you know, we have recently found a security hole in our online university system. One of the students that was using the system found out that he can download all the database of all the users of our faculty. And actually, he wasn't even exploiting the system. He just was following the links. So he clicked one of the links, and then he got the whole database downloaded. Okay, so this part one of the presentation, which is related to modeling of the behavior. And this is the first graph that I'm going to show you, and how you can, as you can see, it's pretty easy. These slots represent consecutive URLs that were sent to the server, which the arrows connecting them to show which were sent to the server after which. And we have this blue square in the middle, which holds the, let's say, legitimate requests from legitimate users. And we have a couple of attack patterns, as you can see, attempts to access, in most cases, phpMyAdmin, which is, of course, the module to access the MySQL database via PHP interface. And this is basically what this part is about, to identify these attempts which differ from daily usage. So my assumption was that with large enough sample of data, it would be possible to identify these usual patterns. And then if we have the usual patterns, then of course we can spot the unusual ones because they differ from the usual ones. So if we have the graph, and if we just add 1 to the number, to the weight of the edge of the graph every time a user traverses a certain path, then in a short time we will have a graph that holds the information about which paths are used often and which paths are very rarely used or just once. And this is an example from my website. As you can see, people who come to my website go to different places, and it was collected over a couple of hours probably, as far as I remember. And they go from, as you can see, from one place to another and back and forth, and sometimes they loop on the same page, but this is clearly understandable, I think. If you don't understand it, then just let me know and I'll explain. This is actually another graph from a bit larger website. And I will show you details in a second, but you can clearly notice that there is a cluster of communication between these pages in the top right corner. And this is what I would say a legitimate use. So they are downloading a couple of core web pages and of course the associated data. And we have several patterns that users only go to specific sites. And as you can see, the weight of the graph is 1, because during this period of time when the graph was built, such transition happened only once. And if you see that graph, it's clear that it's quite easy to identify these attack patterns, because, like I said, they only happen once in a time. So that's the distribution of the weight of the edges, the number of transitions that happened between a certain URL and another URL. And as you can see, there is a large number of very rare transitions that happened only once during the period of the time when the graph was built. And of course, we have popular transitions that relate to typical usage patterns. Now, if we just keep building this graph, and of course, we have to also erode it, so remove some weights from time to time because it may change. Then we have a tool that allows us to identify the suspicious requests, so the request that only has 1 or 2 occurrences during this time. And we can use it for reporting and to notify the administrator that something's going on, or we can probably implement some automated tools that, for instance, would block this certain user for a certain period of time, hindering his ability to probe our website. What is the primary benefit of this graph structure is that it can hold a relatively large amount of data within a small data set. Large servers tend to produce a huge amount of data. I spoke to a man who was working for one of news portals in Poland, and he said, we produce that much data that we cannot analyze it. It's counted in gigabytes per day. That's the amount of log data that we have. And there are no tools for now that would allow us to analyze it in real time. So with this graph, you can store a relatively large amount of knowledge, not data, but knowledge, in a small structure, because the transitions are just increasing the weights of the edges, and it's still 1 byte or a couple of bytes. We can report the attempts in real time, more or less. That depends on the strategy that is implemented. And also, that's maybe not related to security, but is also good beneficial for the websites. We can optimize the performance by pre-caching the web pages if we expect the next page that is going to be loaded. Or we can use it to optimize the websites, for instance, to rebuild the structure in such a way that the most often requested content is easily accessible within 1 or 2 clicks from the start page. What are the problems with this approach that I have come across? First, it's not easy to identify the sessions from the pure local requests. The server usually stores the local requests as they come, one after another. And to have such graph, we need to have sessions. So we need to know which requests come after another. Of course, there are several methods that can be used. One is the use of session IDs. They may not be called SID, but certain frameworks use certain session cookies, session IDs, and so forth. And we can also use referrer to track from one request to another. Of course, the referrer can be forged, but it is of no benefit to the forger because that abuses the path and make it stand out from the crowd. So it doesn't help. Now, another issue that needs to be addressed is to how to filter out the requests made by user, which is for a certain web page, from the request made by the browser once the page is loaded. Because once the page is loaded, then there are a number of references on the page for images, cascading tail sheets, JavaScripts, and all the stuff that needs to be loaded. So I have implemented some logic for that that seemed to work well enough. Maybe not perfect, but it does separate most of these follow-ups. And there is the last issue, which is how to not be overreactive, because sometimes even legitimate users do tend to click something strange. Okay, sorry. And for that, I propose we can use something which I call trust earned, and that is if people or if a user follows a number of transitions that fall into this, let's say, legitimate category, he earns points. And he can earn a couple of points, and then if something strange happens, then we remove these points from his account, thus allowing him to do 1 or 2 strange things once in a while, but still reporting unusual behavior if it is consistent, if a number of requests are still not falling into this usual usage patterns, then we can report it as an abuse. So that concludes the first part, which is related to the behavioral analysis. And if I would to sum it up in just one phrase, it is very perceptive. It can identify almost every single unusual request, but it is also, in my experience, overreactive. That means it produces a lot of false positives. Of course, the number is reduced with this trust and add-on, but still it is a considerable amount of false positives that needs to be addressed. So for that, I developed another layer of identification of requests, and that is based on collective assessments of this request between several servers. How it works. As you also heard in the keynote presentation, there are a lot of people that are hackers. It is democratized. And many people just use ready tools that they download from internet and they just run it like this Bishop. And also there is a lot of malware over internet, like during the first slide when I showed you that Lisa Moon was responsible for 1 million injections during 1 month. So what we see actually is that the same patterns and the same requests for URLs are often repeated between among several servers. So if the servers can share their information about the request they consider suspicious between themselves, and if they can confirm that exactly the same request arrived at a different server, and I consider it suspicious, and the other server considers it suspicious, that means, well, it's 99% not legitimate. Then we have a tool that reduces or also even eliminates the false positives, but still provide us the information about suspicious requests. Of course, we cannot publish the URLs that arrive at the server because they may contain sensitive data for several reasons. But because the servers just need to confirm their findings, so they find out that the URL is suspicious and would like to confirm that other server received the same request, it is enough to use a hash of an URL, because then you have one way to encrypt the hash, and you cannot decrypt the original URL from it, but you can compare it with your own URL and check if it is the same. Of course, for this comparison, the URL needs to be stripped from specific parts like the server, the domain, maybe the installation path, and the arguments, so only this basic web page is hashed. And here's how it looks in my reference implementation. When you have the URLs of encoded in MD5 and some additional data that is used for tuning, like what is the reason this certain URL was reported. In this case, most of the reports were due to the request being not available at the server. If there is a request coming at the server and the server does not have certain resource, like this PHP admin at different URLs, it is also a potential thing to report, because that means something is definitely not as it is supposed to be. And we have the age of the access when it happens. That may also be used for fine-tuning of the reporting algorithm. And the C in the beginning is something that I do not use anymore, but it means whether the report is forwarded from other website, or is it originated at this specific place? So here's how it looks and how I build it. Unfortunately, or maybe unfortunately, I had to add some specific export rules to remove certain requests from being processed. Because quite often we have requests for things that are very common and missing, like favicon.ico. You know what this file is? That's the icon of the website, and many websites do not have it, but still browsers request this file, or robots.txt as well. So to remove the number of false positives. Yes, I know, I'm approaching the final slide. To remove this potentially not interesting requests, they are being removed at the early stage. Then this information about unusual requests that are identified at the website, plus the information about the request that generated the missing response, are forwarded to the module that checks if it is okay or not to report them based on the analysis of the graph, and by removing this, like I said, usual missing files. And the list is published just by the means of normal web server as a web page. And also, same list is downloaded from another servers periodically from time to time. And then if certain requests is on my list and is on another server list, it is reported to the administrator. Now, that's probably the most interesting part. So I run this system for a year on 3 small servers. Unfortunately, I only have access to such small servers because large companies I spoke to were not very keen to give me access to their log files. And in this environment, I was able to detect about 30% of all attack attempts. And this number is low because of this low volume of traffic that was coming to the servers. However, the bright point is there were no false positives at all. So you get a tool that can report some of the attack attempts without the need for prior training and without any false positives, which is, of course, something that every administrator would cherish, because I know I spoke to some that need to come to the office at 3 o'clock in the morning just to find out that their IDS was overreacting. All right, well, that's the conclusion of my presentation. And of course, if you have any questions, I'm happy to answer them. Yes, please. I will be repeating the questions because that's what I was asked from the organizers, so they can record it. So the question is, what happens during the learning phase if there are malicious requests coming from the internet, right? Well, there's no problem, because as long as they do not constitute a majority of the requests, they will still end up in the graph having very low edge value, right? So, and also I clean up the graph periodically. So from time to time, I reduce the weight of the edges. And so the transitions that do not happen, they just disappear with time. And then if something, the same request comes in, say, a couple of days, there's no memory of it, so it is also reported as unusual. So as long as the number of malicious requests is low within the whole volume of traffic, That is not a problem. Yes?
How do you know that you have reached a certain limit or enough data to take decisions based on this?
Well, there's no strict rule, but usually if you have, that depends on the amount of traffic. If you have high amount of traffic, probably even a couple of hours is enough. If you have low amount of traffic, probably you need a couple of days. So you have, like I said, a good ratio because between the good requests and the bad requests, and you have all the good requests covered. So if you know how many time you need for users to basically go through all your sites a couple of times, that's the time of you need to reserve for the learning. Yes, you had a questions.
Yes, it all looks pretty interesting, but how can I use it? Like if I want to try it at our company, how would I start using it? Like, do you have a website, a GitHub account? Is it open source?
Not yet. I mean, I'm working for a university, so at the moment there's a possibility to get a license for the codes to use it freely. I'm processing a path to get it open source, so to say, but it requires a certain amount of approval from deans and other officials from the university. So if you want to use it, please contact me and we'll arrange for you to get the codes. That's it.
Thank you.
Yes, please.
If you restricted the scope to just one site, and would you be able to detect things like forced browsing attempts to bypass access control and things like that?
Once again, can you repeat the beginning of?
If you restricted the scope to just one website,
Yes.
could you detect things like forced browsing? Could you do it in
Yes, the question was if I can use the system if it is just restricted to one website. That was the first part of my presentation. Building the graph is just meant to be done on one website, and then you have a reporting on unusual behaviors. The second part, which is the collective detection, is used to reduce the number of false positives. So with the graph, the behavior graph built with just one website, you will have the detection of unusual behavior, but you will have also some positive false positives. How many, that depends on this trust-owned parameter that allows the user to behave unusually from time to time, and of course on the behavior of the user and the number of traffic. With larger quantities of traffic, the relative number of false positives will be lower. Yes?
You do comparing requests, restrict them from the main, restrict them from certain parameters, but still something left. There could be that some parameters are specific for session, let's say some timestamp.
Yes.
And then the order of parameters, well, this still would be the same request, the order is changed. So you need to do some canonization.
All right. So the question is what to do in case when the parameters are used to navigate this website, right? That's what I understand more or less. So, this method does not address this problem. I did some research with my colleague some time ago on statistical analysis and some other means of analysis of parameters that come with the requests to identify usual and unusual patterns. And as it happens, there are some tools that can be employed, like I said, character distribution or the length of parameters and things like that, that allow us to identify with certain certainty that this parameter is within the expectable limits, but that's outside the scope of this project. Any more questions? Yes, please.
Did you have the chance to try it on websites that use a lot of rewriting? Because, for example, some e-commerce technologies or websites, they will create unique URLs even if you just do some specific
All right, so the question is how to employ it to a website that uses URL rewriting for accessing certain pages. Well, that depends. If the rewriting is done always in the same way, so people accessing next pages get the same rewrites, then it will work. If you get rewrites that are specific for user sessions, so you have some information that is stored in the URL that is related to the session, that it won't work. Yes, there was a question. Yes, please. Yes. Okay, so the question is how this handles the changes to the websites if they change from time to time. Well, this graph adapts, so it grows with the website and it is periodically destroyed. So if the website is more or less the same from day to day, the erosion of the graph is countered with the inflow of new requests that keep the graph at the same stage. Now, if we remove some parts of the website, there will be no requests coming to these certain URLs, and this portion of the graph will erode and disappear in time, let's say in a couple of hours or a couple of days, depending on how much traffic do you have. So, and at the same time, another part of the graph will grow up. Of course, during this transition, you will get a lot of false positives. So the only thing you need to be aware that when you change the website, the graph will start reporting that something is going wrong because people will start access new content that has not been yet recorded in the graph. So just for some time, you have to ignore the output of this system. Any more questions?
You've been exploring like options to do the conversion between different websites in the first stage, like having a pattern of suspicious activity and then comparing it to another pattern on another website. Like having okay, this guy does like 3 requests in a certain path, and that guy on another website does kind of the same thing, so compare them.
All right, so the question was how to compare the behavior of users at different websites if they do certain patterns of the requests. Well, this system is much simpler right now, so it doesn't compare patterns between the websites. It just analyzes the pattern of requests at one website and compares certain single URLs between the websites. So we do not compare, so I do not compare patterns between websites yet. That's not done yet, but maybe a good thing for the future. Yes, it is working in real time. I mean, I haven't had chance to test it on huge websites, but the implementation is in Java, and I think it can process thousands of requests per second easily at this stage without any optimization. So it doesn't require much processing power. Any more questions? Then thank you very much for coming. And hope to see you around.